Good morning all. In the last class we have studied about the relation between the partial derivatives and the continuity. And in that section we have a question that the partial derivative exists imply f of xy is continuous or not. The answer is it need not be. So for that example I have showed in that videos f of xy equal to 0 and xy not equal to 0 and 1 if xy equal to 0. At that position f of xy equal to f of 0 equal to 1, but all the other limits tends to 0. So this function f of xy is not continuous, but the partial derivative exists. This is an example for that function. Then what will be the condition for that? A function which have partial derivative exists at a point x naught y naught implies the continuity. So partial derivative exists and are continuous throughout a disk centered at x naught y naught. Then we say that f is continuous at the point x naught y naught. Here we can say that this f is not continuous at 0 0. Here f is continuous at x naught y naught if the partial derivative exists and are continuous throughout the disk centered at x naught y naught. Then only we can say that f is continuous at this point. This is x naught y naught. X naught y naught. This is the disk. Right. Move on to the second order partial derivatives. What is the meaning of partial derivative? Second order. Dou square f by dou x square, mainly 4 types of second order partial derivatives. Dou square f by dou x square, dou square f by dou x dou y, again dou square f by dou y dou x, dou square f by dou y square. Then what will be dou square f by dou x square, that is dou by dou x of dou f by dou x. Dou square f by dou x dou y implies dou by dou x of dou f by dou y. And what will be this one? Dou by dou y of dou f by dou x. This is dou by dou y of dou f by dou y. That becomes dou square f by dou y square. An example, I am going to do first and second order partial derivatives of a function. Consider the function f of xy equal to x cos y plus y e raised to x. Find all its first and second order partial derivatives. The solution f of xy equal to x cos y plus y e raised to x. Then find the dou f by dou x. What will be that? Dou by dou x of f. That is x cos y plus y e raised to x. Dou by dou x of x cos y plus y e raised to x means dou by dou x of the derivative of this one with respect to x and derivative of this term with respect to x. Derivative of this term with respect to x means cos y is a constant with respect to x. So x is the only variable here. So derivative of x is 1. So 1 into cos y plus y is constant. The derivative of e raised to x is e raised to x itself. So the answer is cos y plus y e raised to x. And next, dou f by dou y. Dou f by dou y. Dou f by dou y equal to dou by dou y of x cos y plus y e raised to x. So derivative of x cos y plus y e raised to x with respect to y by treating x as constant. So x is constant, so x into derivative of cos y, that is minus sin y, plus derivative of y e raised to x. E raised to x is constant, so derivative of y is 1. So minus x sin y plus e raised to x is the answer. So the second order partial derivatives are dou square f by dou x square, dou square f by dou x dou y, dou square f by dou y dou x, dou square f by dou y square. These are the second order partial derivatives. How to calculate this dou square f by dou x square? That is dou by dou x of dou f by dou x. That is dou by dou x of dou f by dou x. We know that is cos y plus y e raised to x. Derivative of cos y with respect to x means 0. Derivative of y e raised to x with respect to x. Here y is constant. Derivative of e raised to x is e raised to x. So the answer is e raised to x, y e raised to x. Again dou square f by dou y square. That is dou by dou y of dou f by dou y. That is dou by dou y of minus x sin y plus e raised to x. That is minus x cos y minus x derivative of sin y cos y. This is the with respect to x. This is with respect to y e raised to x derivative equal to 0. So minus x cos y. Again dou square f by dou x dou y. That is dou by dou x of dou f by dou y. That is dou by dou x of minus x sin y plus e raised to x. That is minus sin y plus e raised to x. Here with respect to when we are differentiating with respect to x, derivative of x equal to 1. So this is minus sin y plus e raised to x. Again dou square f by dou y dou x equal to dou by dou y of dou f by dou x. That is dou by dou y of cos y plus y e raised to x. Cos y derivative is minus sin y e raised to x in this term. E raised to x derivative is e raised to x itself. That is constant, and y derivative of y is 1. So 1 into e raised to x. So minus sin y plus e raised to x. This is the answer. Look this. Dou square f by dou x dou y. These are the dou square f by dou y dou x. This can be represented as fxy at the point AB and fyx at the point AB. Fx and this is another representation also. Next what? Look at these example. In this example, we have found that dou square f by dou x dou y and dou square f by dou y dou x. This is minus sin y plus e raised to x. Again, this is minus sin y plus e raised to x. Is there any relation between these two? Are they same? The answer is very simple. By using, we have a result, that is Euler's theorem. Euler's theorem or mixed derivative theorem says that answer. These are same when these conditions must be satisfied. Euler's theorem says that if a function f of xy and its partial derivatives fx, fy, fxy, fyx are defined throughout an open region containing a point AB and are all continuous at AB, then we say that fxy at AB equal to fyx at AB. This is the Euler's theorem. Once more, if f of xy and its partial derivatives, these are the partial derivatives up to the second order, are defined throughout an open region containing the point AB and are all continuous at AB, then we can say that this is the important one, continuous at AB. Then f of x, fxy at AB equal to fyx at AB. In this example, this function is continuous. So we got that these two derivatives are equal. Okay. So next you have to do some homeworks. I will give some questions in this. Okay, I will show this question. You write it down and I will show it through the WhatsApp. Right. This example. Find dou square w by dou x dou y w equal to xy plus e raised to y by square plus 1. Second one, find all second order partial derivatives. First question, f of xy equal to x square y plus cos y plus y sin x. B, h of xy equal to x e raised to y plus 1. F of xy equal to natural log x plus y. Third question, verify the Euler's theorem. First one, w equal to natural log 2x plus 3y. Second, w equal to x sin y plus y sin x plus xy. Third one, w equal to xy square plus x square y cube plus x cube y raised to 4. And the fourth one, find the value of dou x by dou z at 1, minus 3 if xz plus y log z minus x square plus 4 equal to 0. Here x is a function of y. X is a function of y and z. Again, 2 or more question. Find dou z by dou x at the point 1, 1, 1. If the equation xy plus z cube x minus 2yz equal to 0, z is a function of x and y. Okay. Sixth question, show that f of xyz equal to x square plus y square minus 2z square satisfies the Laplace equation. This is the Laplace equation. Laplace equation in 2 dimension means dou square f by dou x square plus dou square f by dou y square equal to 0. This is a second order equation. This is a this is a 2 variable equation. This is in 3 variable. Again, show that f of xy is equal to, show that it satisfies the Laplace equation. F of xyz is changed to 2z cube minus 3 into x square plus y square into z. And again, one more f e raised to 3x plus 4y into cos y into 5z. Okay, thank you.